Okay, question 4. We've got some water in a tank. It tells us that the bottom of the tank has an area of 0.8 meters squared. It tells us that the force on the tank is 2,400 newtons from the weight of the water above. And it says calculate the pressure. So we know pressure equals force over area. That's in newtons, that's in meters squared. What's the answer in pascals? But we know that's the same as newtons per meter squared. So no unit change. So pressure equals force over area, 2,400 divided by 0.8 equals 3,000. So that's a nice start. We add some more water into the tank. So that's going to increase there. And we're going to have a greater weight of water above the that column in that area. So explain how the pressure changes when water is added to the tank. So we've got to say what will happen to it in that the pressure will go up, and then explain it in terms of the weight of the water above. So there'll be a greater pressure on the bottom of the tank as there'll be greater weight of water above that area at the bottom. Next one, we've got an object at the bottom of a tank, and it says draw the arrow to show the direction of the force. And as we know, the forces are perpendicular to the surface. So I'm going to need an arrow that's 90 degrees to the surface. So that's that arrow there. Next question, we've got a graph and it tells us the height and the pressure. And we can see as we increase in height, we decrease in pressure. An aeroplane descends from 6,000 to 2,000. Find the change in atmospheric pressure. So it's find this change, read it across, and then find that change. So we've got 80 to 50, so that change must be 30. We can write that in there. Suggests one reason why the atmospheric pressure is greater at 2,000 than 6,000, so any one of these things. Air is denser at 2,000 than 6,000. There's a greater weight or depth of air above the plane at 2,000 than 6,000, and the temperature is higher at 2,000 than 6,000. And obviously you could use the reverse arguments for each of those. And then the last part is we've got a person lying on a bed or standing on a bed, and we can see the pressure's greater there because we've got more crinkly bits. Explain why the person exerts a different pressure. So ultimately this is the same person, so they're going to have the same weight. So they've got the same weight, and that's our force. Always get your equations out to help you with this. We know that pressure equals force over area. That bit has stayed the same. And then here we've got a greater area. And if we've got a greater area, that force will be spread out over a greater area, so there'll be lower pressure. I mean, what we're saying is this number goes up, so that force is this number to go down, because that stays the same. So when lying down, the person has a greater surface area, 1 mark. And then use your equation, pressure equals force over area, the weight is the same and will be spread over a lower area, which will give a lower pressure. Question 3.